FM radio broadcasting explained. FM broadcasting is a method of radio broadcasting that uses frequency modulation, FM, of the radio broadcast carrier wave. Invented in 1933 by American engineer Edwin Armstrong, wideband FM is used worldwide to transmit high-fidelity sound over broadcast radio. FM broadcasting offers higher fidelity, more accurate reproduction of the original program sound, than other broadcasting techniques, such as AM broadcasting. It is also less susceptible to common forms of interference, having less static and popping sounds than are often heard on AM. Therefore, FM is used for most broadcasts of music and general audio, in the audio spectrum. FM radio stations use the very high frequency range of radio frequencies. Frequency modulation, FM, is the encoding of information in a carrier wave by varying the instantaneous frequency of the wave. The technology is used in telecommunications, radio broadcasting, signal processing, and computing. In analog frequency modulation, such as radio broadcasting, of an audio signal representing voice or music, the instantaneous frequency deviation, that is the difference between the frequency of the carrier and its center frequency, has a functional relation to the modulating signal amplitude. Digital data can be encoded and transmitted with a type of frequency modulation known as frequency shift keying, FSK, in which the instantaneous frequency of the carrier is shifted among a set of frequencies. The frequencies may represent digits, such as 0 and 1. FSK is widely used in computer modems, such as fax modems, telephone caller ID systems, garage door openers, and other low-frequency transmissions. Radio teletype also uses FSK. Frequency modulation is widely used for FM radio broadcasting. It is also used in telemetry, radar, seismic prospecting, and monitoring newborns for seizures via EEG, two-way radio systems, sound synthesis, magnetic tape recording systems and some video transmission systems. In radio transmission, an advantage of frequency modulation is that it has a larger signal-to-noise ratio and therefore ejects radio frequency interference better than an equal power amplitude modulation, AM, signal. For this reason, most music is broadcast over FM radio. However, under severe enough multipath conditions it performs much more poorly than AM, with distinct high-frequency noise artifacts that are audible with lower volumes and less complex tones. With high enough volume and carrier deviation, audio distortion starts to occur that otherwise wouldn't be present without multipath or with an AM signal. Frequency modulation and phase modulation are the two complementary principal methods of angle modulation. Phase modulation is often used as an intermediate step to achieve frequency modulation. These methods contrast with amplitude modulation, in which the amplitude of the carrier wave varies, while the frequency and phase remain constant. Now let's look at demodulation for FM radio. Many FM detector circuits exist. A common method for recovering the information signal is through a Foster-Seeley discriminator or ratio detector. A phase-locked loop can be used as an FM demodulator. Slope detection demodulates an FM signal by using a tuned circuit which has its resonant frequency slightly offset from the carrier. As the frequency rises and falls, the tuned circuit provides a changing amplitude of response, converting FM to AM. AM receivers may detect some FM transmissions by this means, although it does not provide an efficient means of detection for FM broadcasts. In software-defined radio implementations, the demodulation may be carried out by using the Hilbert transform, implemented as a filter, to recover the instantaneous phase, and thereafter differentiating this phase, using another filter, to recover the instantaneous frequency. Alternatively, a complex mixer followed by a bandpass filter may be used to translate the signal to baseband, and then proceeding as before. FM is also used at audio frequencies to synthesize sound. This technique, known as FM synthesis, was popularized by early digital synthesizers and became a standard feature in several generations of personal computer sound cards. Edwin Howard Armstrong, 1890 to 1954, was an American electrical engineer who invented wideband frequency modulation, FM, radio. He patented the regenerative circuit in 1914, the superheterodyne receiver in 1918 and the superregenerative circuit in 1922. Armstrong presented his paper, A Method of Reducing Disturbances in Radio Signaling by a System of Frequency Modulation, which first described FM radio, before the New York section of the Institute of Radio Engineers on November 6, 1935. The paper was published in 1936. As the name implies, wideband FM, WFM, requires a wider signal bandwidth than amplitude modulation by an equivalent modulating signal. This also makes the signal more robust against noise and interference. Frequency modulation is also more robust against signal amplitude fading phenomena. As a result, FM was chosen as the modulation standard for high-frequency, high-fidelity radio transmission, hence the term FM radio, although for many years the BBC called it VHF radio because commercial FM broadcasting uses part of the VHF band, the FM broadcast band. FM receivers employ a special detector for FM signals and exhibit a phenomenon known as the capture effect, in which the tuner captures the stronger of two stations on the same frequency while rejecting the other. Compare this with a similar situation on an AM receiver, where both stations can be heard simultaneously. However, frequency drift or a lack of selectivity may cause one station to be overtaken by another on an adjacent channel. Frequency drift was a problem in early, or inexpensive, receivers. Inadequate selectivity may affect any tuner. An FM signal can also be used to carry a stereo signal. This is done with multiplexing and demultiplexing before and after the FM process. The FM modulation and demodulation process is identical in stereo and monaural processes. A high-efficiency radio frequency switching amplifier can be used to transmit FM signals, and other constant amplitude signals. For a given signal strength, measured at the receiver antenna, switching amplifiers use less battery power and typically cost less than a linear amplifier. This gives FM another advantage over other modulation methods requiring linear amplifiers, such as AM and CAM. FM is commonly used at VHF radio frequencies for high-fidelity broadcasts of music and speech. Analog TV sound is also broadcast using FM. Narrowband FM is used for voice communications in commercial and amateur radio settings. In broadcast services, where audio fidelity is important, wideband FM is generally used. In two-way radio, narrowband FM, NBFM, is used to conserve bandwidth for land mobile, marine mobile and other radio services. There are reports that on October 5, 1924, Professor Mikhail Bonch-Bruevich, during a scientific and technical conversation in the Nizhny Novgorod Radio Laboratory, reported about his new method of telephony, based on a change in the period of oscillations. Demonstration of frequency modulation was carried out on the laboratory model. Alrighty, that's it for this video folks. Remember to like, share, comment, and subscribe, and I will see you in my next video. Bye for now.